Good afternoon, everyone. In this video, we are going to discuss how to solve one of the more concept question paper extracted from 2016 GCE past paper. Now, here is the question that we are going to work out. The question reads, when carbon dioxide gas is bubbled through aqueous calcium hydroxide, lime water, the following reaction occurs. So here the calcium hydroxide is lime water, and this is the equation that is given. Question A reads, write a word equation for this reaction. So meaning yours is just to translate this equation into word. Right now it is in chemical equation. Now they want you to use the actual words for these substances here. So the first one, this is calcium hydroxide. So you just write calcium hydroxide plus, this is carbon dioxide plus carbon dioxide. This one is giving us calcium carbonate plus water. That is the answer, just in weight. Coming to B, if 1.2 decimeter cube of carbon dioxide gas measured at RTP was bubbled through excess calcium hydroxide solution, calculate the mass of calcium hydroxide solution which reacted. So in this case here, we are asked to find the mass of calcium hydroxide, the reactant here, the first reactant, the mass of this one which reacted in the equation. So they've just told us that the reaction, the amount of calcium hydroxide, it was in excess, meaning it was too much. So meaning the one which was determining the product to be produced, it is the carbon dioxide because it is limited. So in this case, they want us to know how much mass reacted with carbon monoxide to produce this calcium carbonate and the water. So now we are going to use what we've been given. So in this case, we've been given the volume of carbon dioxide. That is what we've been given. So we are going to use this volume to come up with the mass of calcium hydroxide. Now the question is, how do we use this volume so that we come up with the mass of this calcium hydroxide? So now here, quickly, we have to remember, because they've said this gas, this 1.2 decimeter cube of carbon dioxide gas, it was measured at RTP, which is room temperature pressure. So in this case now, we are going to use that mole relationship, that molar volume relationship, which says 1 mole is equivalent to 24 decimeter cube. So meaning any 1 mole of any substance, 1 mole of any substance is always equal to 24 decimeter cube. So now we are going to convert this volume to moles, because moles are the general amount, are general quantities that can help us to find anything that we want, be it mass, be it volume, or be it percentage yield, be it molecular masses, or the empirical formula. We always deal with the moles. So moles are really unique. So whatever we've been given, we have to make sure that we convert them to moles. So we'll convert this 1.2 decimeter cube to moles using that relation. 1 mole is equal to 24 decimeter cube. Or we use this formula here. Which is number of mole is equal to volume over molar volume. It is the same thing. Whether you use the one that I said, 1 mole is equal to 24 decimeter cube, or this formula, it will still give you the same answer. So what we have in the formula here, the N represents the number of moles, and the V represents the volume which is given. And then the molar volume, that is the standard volume, which is the 24 decimeter cube that I'm talking about. So this is the formula that we're going to use. So in this case, the V, it is that one which we have 1.2 decimeter cube. over now the 24 decimeter cube. So our solution, when we substitute, this is what we are going to have: the 1.2 on top there, and then down there we have the molar volume, which is now the 24 decimeter cube. So now when we get now the answer, what we have there, that is the number of moles of carbon dioxide, because this volume, it is for carbon dioxide. And when we convert it to moles, meaning we've just found the number of moles of carbon dioxide. So this, it does not relate to the calcium hydroxide. This is just the number of moles of of carbon dioxide. So now, after finding these moles, what else should we do so that we get to the answer? We get to know the mass of calcium hydroxide that reacted. So now, here is what we are going to do. This is our equation that was given. So now, since we know the number of moles of carbon dioxide, what we are going to do, we are going to make sure that this very equation that we have here, it is balanced. We have to make sure that our equation that we have, it is balanced. So when you check it clearly, or when you try it on a piece of paper, this very equation that we have here, we are very lucky, ladies and gentlemen. This equation here, it is well balanced. It is already balanced as it is given. So now what we are going to do is we are going to compare now the mole ratios. What I mean by mole ratios is the coefficients, the numbers in front of carbon dioxide, which is given, and also for calcium hydroxide, which we want to find. So what are the coefficients? The numbers that are in front of those chemical formulas. So let's see, what is the coefficient, or rather the mole ratio of calcium hydroxide? So the mole ratio, it is 1 there because there's no number that we are seeing in front there. That means there's a number which is 1 there. When you look at carbon dioxide also, there's 1 there. So meaning the mole ratio is 1 to 1. Don't get me wrong. These are the numbers, the 0.05, these are the moles. These are the actual moles that reacted. But here, this is the mole ratio, the numbers in front in a balanced chemical equation. So we've seen that it is 1 to 1. Then here is what we are going to do. So, meaning I have gotten this, the calcium hydroxide, because this is what we are trying to find for. And I will compare it with carbon dioxide because these are the two that reacted. So now the mole ratios, as usual, it is 1 to 1. Then what are the number of moles of carbon dioxide? That one we have. So we are trying now to compare so that we get to know the number of moles of calcium hydroxide. So now, in this case, for carbon dioxide, we have 0.05, the number of moles that we calculated. Then coming to calcium, do we know the number of moles of calcium hydroxide? We don't. No wonder it is presented by letter X there. So after doing that, what should we do now? We are going to cross multiply like that. So meaning X times 1, it will give us something like this. This is the solution. Since it is 1 to 1 ratio, meaning the number of moles of carbon dioxide and the number of moles of calcium hydroxide will be equal to each other because the ratio there, it is 1 to 1. So meaning this answer, which is here, the 0.05 mole, this is also the number of moles of calcium hydroxide. Now at least we have something that relates to calcium hydroxide. We have the number of moles of calcium hydroxide. Now, how do we get to know the number of mass, having known the number of moles? So now here, you introduce in another formula. If you have mass and you have the chemical formula, how do you find now the mass? So now, there's this formula that we use. Number of moles is equal to mass over molar mass, because the number of moles we have. The molar mass you can find, that is the relative molecular mass. So now, what is the relative? So now, since you are finding the mass of calcium hydroxide, so the relative molecular mass that we are going to put there, it is for calcium hydroxide. Because if you use for carbon dioxide, meaning you are finding the mass of carbon dioxide. So now you have to calculate the relative molecular mass of calcium hydroxide. So calcium there from the formula calcium hydroxide, we have one calcium atom there. So you multiply it by its mass, which is 40, giving us 40 when you multiply. Then you look at the oxygen which are in the formula. They are 2. So we are going to multiply 2 by 16, the mass number of oxygen, which will give us the 2. Then we have 2 hydrogen atoms there, times 2, times 1, the mass number of hydrogen. And that, of course, will give us 2. When you add all those together, you will definitely have 74. So the molar mass of calcium hydroxide, it is 74. And the number of moles of calcium hydroxide we found to be 0.05 mole. So you will substitute there now in your equation. So in this case, we have where there is N, we substitute the 0.05. That is the number of moles of calcium hydroxide, giving us mu, that is the mass that we are trying to find, over the molar mass of calcium hydroxide, which is 74. Then you perform calculations there. So when you perform calculations there, meaning here to be over 1, then mu will give us 3.7 gram. This is the answer. This is the mass of calcium hydroxide. Okay, coming to the second question. Calculating the mass of calcium carbonate formed. So calcium carbonate, that is the product now, because we have 2 products. We have calcium carbonate and also water. So how do we find now the mass of calcium carbonate? Here, colleagues, ladies and gentlemen, it is the same working process. There's nothing that is difficult here. The first thing, the whole idea is we know our limiting reactant. Our limiting reactant is carbon dioxide. So we'll be comparing everything for carbon dioxide. Not really everything, but the number of moles of carbon dioxide and its mole ratio with the one that we are trying to find. So in this case, they want us to find for the mass of calcium carbonate. So we are going to compare now the mole ratios of carbon dioxide, that is the limiting reagent. No wonder we were given that one so that we use it to find the solution for these questions. So in this case, we are going to compare carbon dioxide with calcium carbonate. This is what we are going to do. So we have carbon dioxide here and also calcium carbonate. So as usual, just compare their mole ratios, because you don't need to calculate now the number of moles of carbon dioxide. You already did. So just go direct, compare their mole ratios. So their mole ratios from the balanced equation, they are just 1 to 1, because carbon dioxide there, it is 1. Now, when you're comparing, make sure that you use the balanced equation. So I'm getting these numbers from the equation. The coefficient of carbon dioxide there, it is 1. When you look at calcium carbonate, which is the product there, it is also 1. So meaning it will be 1 to 1. Then, what else do we know for carbon dioxide? We have the number of moles. Put them there. What? Put them there. So the number of moles of calcium, of carbon dioxide, it is 0.05. Then what do we know about calcium carbon? Do we have anything there? Nothing. So we put X so that we know when we perform these calculations here, what we are going to find, we'll find the moles of calcium carbonate. Then you multiply there, the 1 times X will give us X. The 1 times 0.05, it will still give us 0.05, which is that one. So these moles now, these are the number of moles of calcium carbonate. We will do the same thing. How do we get the mass? We use that other formula that we used there. So number of moles is equal to mass over molar mass. Where there's N, we substitute the 0.05 moles of calcium carbonate. Where there's M, still remains M, because that is what we are trying to find. over the which is the relative molecular mass of calcium carbonate. So here, since we are finding a mass of calcium carbonate, so the number of moles here, the molar mass here, it will be for calcium carbonate. So calcium carbonate, that is the formula which is there. You do as usual. How many calcium atoms are there? We have 1 times the mass number of calcium, which is 40. When you multiply, definitely you have a 40. Then what else? What atom do we have there in calcium carbonate? We have carbon, and there's only 1 carbon atom. So you say 1 times the mass number of carbon, which is 12. You get 12. Then we have oxygen, 3 atoms. So you multiply 3 times 16, which is the mass number, which will give us 48. When you add it together, you have definitely 100. So you substitute there in the equation. So the 0.5 is there, is giving us the mass there, and then the 100, which is the molar mass of calcium carbonate. Then you perform some calculations there, you cross multiply, and then the answer will be 5 grams. That is the mass of our calcium carbonate. Therefore, there is another question. Which said what will happen when you bubble the carbon dioxide in. So here is the solution. The solution now will be a white precipitate will be seen. Thank you very much for watching this video. Wait for some more videos.